Hello. Well, today I'm going over one of these practice final exams from Alex. Here's the first question. Solve this inequality. Notice the denominators 3 and 9. That means if I multiply both sides of this inequality by 9, we'll get rid of all the fractions. If we do 9 times this side, 9 times 2, 18. And 9 times 4/3 is 12, so we get minus 12v there. On the other side, 9 times 7/3 is 21, and then minus 9 times 5/9 is 5, so we have 5v. Then I added 12v to both sides, and that leaves the 18 by itself on the left side. We have 21 plus 7v, minus 5 plus 12, that's 7v. Take away 21 from both sides, and you got 7v is less than or equal to negative 3. And so finally divide by 7, you get v is less than or equal to negative 3. Now, for this next thing, there's not enough room here for solving this absolute value inequality, so I went to another piece of paper and got started. When you have an absolute value inequality greater than equal to some number, and I use d most of the time because it is sort of a distance idea, the solution will look something like this. It'll be all the numbers on the number line except for some gap in the middle. It'll be everything from a certain number on down together with from a certain number on up. And in interval notation, it'll get represented as a union of two intervals from negative infinity up to a number, union with from a certain number up to positive infinity. And the way we arrive at this solution algebraically is to solve two inequalities. One, where we just eliminate the absolute value bracket. And I could talk about why that is for 20 minutes, but this is not the time. I solve this, take away 10 from both sides, and then we have 4x greater than or equal to negative 4. Then I divide by 4, and I get x greater than or equal to negative 1. Now, the other inequality we solve is where we drop the absolute value bracket, and at the same time, we make two changes. We change that symbol direction, and we change that number's sign, and then solve this. So again, I would take away 10 from both sides. Then I would have 4x less than or equal to negative 16. And then if I divide by 4, I get less than or equal to, x is less than or equal to negative 4. And if I go back to this picture, let me redraw it over here. Put these two statements together with this picture, and it starts to make a lot of sense. The number is greater than or equal to negative 1. Well, that is over here. The number is less than or equal to negative 4. That's that collection of numbers to the left of negative 4. Written in interval notation, we would say negative infinity up to, including negative 4, union with negative 1 up to positive infinity. Okay, well, that's question 2. I'm going to go back on the paper for question 3. Question 3 is just factoring by grouping. So looking at these two terms independently, do you see a common factor of 2? I mean, you get 3y squared minus 2w. And a common factor there of y, and you get y times w minus 24. And we don't have any match there, do we? So that tells us this ordering is probably not going to help us. So you change the order a little bit, and you could do that by switching these two, Probably switching these two won't make a difference, but get this swapped for one of those and see what happens. So I'm going to write 6y squared and plus yw, and then the minus 4w, and the minus 24y. And now we'll see what happens. So from these two terms, now I can factor out a y and write y times 6y plus w. There's 6y squared plus yw, or wy. From these two, I can factor out minus 4 times w. And to make this a minus, I need a plus here. Plus what? Plus 6y. These are the same. The order's backwards, but with addition, it does not matter. W plus 64 is plus 6y. I made my y look like a 4. 6y plus w is the same as w plus 6y. So that's the common binomial factor we can pull out to the front and make my y look like a y this time. And the other set of parentheses, y minus 4. And last, I'm going to factor this. And you could do guess and check, or you can do the AC method. A and C are 15 and 2. 15 times 2 is 30. Now we need numbers that multiply out to 30 and add up to 11. How about 6 and 5? So we rip apart the 11x, making it 6x plus 5x instead. Let me do that over here. All right, 15x squared plus 6x plus 5x plus 2. Okay. And I could have put the 5x there and the 6x there. It doesn't matter. So for these two terms, common factor would be 3x. 3x times 5x plus 2. And there's no common factor here except for the wonderful number 1, which is going to save the day because we have to have something. 1 times 5x plus 2. And everything's fine because these are a match. So our answer is 5x plus 2. 3x plus 1. Okay, and that takes care of page 1.